With the rapid development of artificial intelligence and robotics, the robot chassis has evolved from a basic mobile platform to an intelligent core component. So, how are robots making their mark in various industries, and how is AI technology enhancing robot intelligence? Today, we will take you on an in-depth look at robot chassis technology, discussing its impact on different industries, future trends, and the challenges and opportunities it faces. As the heart of a mobile robot, the chassis system enables the robot to efficiently perform tasks with the required precision and agility. First, let's learn about mobile robot chassis by watching the video.
With the continuous development of human society, robot technology is also advancing rapidly, and robots have made significant improvements in functionality and performance. So, how are robots created? Now, we will take Reeman Robot Company's Moon Knight 3.0 product as an example to understand some of the main components of robot manufacturing through 3D demonstration. The first is LiDAR, which is used to create maps and scan the environment for localization by measuring the reflection time between a laser beam and an object. This enables the robot to generate high-precision three-dimensional maps and achieve precise navigation in complex environments. Lithium iron phosphate batteries are widely used due to their high safety, stability, long life, and other advantages. These features ensure that the robot has a reliable power supply, allowing it to operate for long periods of time. The 3D camera can capture depth information and provide the robot with three-dimensional obstacle avoidance capabilities. Not only can it identify and avoid obstacles ahead, it can also detect differences in the ground to prevent the robot from falling or colliding. The navigation mainboard undertakes the calculation tasks of the navigation algorithm and provides the navigation path required when the robot is running. In addition, it also works with other peripherals to implement functions such as obstacle avoidance, fall prevention, scheduling, and one-click calling, and provides hardware support for the website. Android motherboards are mainly used for the development and testing of Android applications. It is responsible for screen display and operation, and provides hardware support for application development. The function of the power strip is to provide a stable power supply and convert the power supply's electrical energy into various voltage and current levels to meet the power needs of the robot's computer hardware and other equipment. An in-wheel motor is an electric drive system that integrates an electric motor directly into the wheel and a built-in encoder to measure the wheel's rotation. This allows the robot to accurately measure its distance traveled and angle of rotation, allowing for precise navigation. The main function of the drive box is to provide power, signal, and protection to ensure accurate movement and control of electric equipment or actuators as required. A gyroscope is a device used to measure or maintain direction. It can detect changes in the angular velocity of a robot, thereby helping the robot understand its current attitude or direction and ensure stable movement. The suspension system helps the robot adapt to uneven ground, reduces vibration, and maintains the robot's stability. This system can include springs, shock absorbers, or other shock-absorbing devices to absorb shock caused by uneven ground and ensure that the robot chassis remains level. Universal wheels help achieve multi-directional movement, allowing robots and automation equipment to move flexibly in various environments while maintaining product balance. Through the combination and collaborative work of these key components, the robot can achieve high-precision positioning, navigation, obstacle avoidance, and stable movement, thus becoming a powerful assistant in various application fields. Continuous advances and innovations in robotics will continue to propel our society to greater heights.
Next, let's take a look at the current state of the global robot chassis market. According to Grand View Research, the global mobile robotics market will reach $25.4 billion by 2024 and is expected to grow at a CAGR of 20.7% from 2025 to 2030. Robotic chassis systems are particularly notable in this continuing growth trend. The Mobile Robot Chassis Market Report mentions that the global mobile robot chassis market is estimated at $1.6 billion in 2023 and is expected to grow to $4.5 billion by 2032, at a CAGR of 11.5%. This growth is mainly attributed to several factors, including the industry's need for efficient operations and precise execution of tasks, continuous advancements in robotics, and increasing requirements for safety and sustainability. The global mobile robot chassis market exhibits unique trends across regions, with market demand in each region being driven not only by industrial automation, but also by the convergence of artificial intelligence technologies that are shaping the future of these markets. North America, Europe, and Asia Pacific, especially China and Japan, are the major drivers of the growing demand for robot chassis. Latin America and the Middle East, on the other hand, are late starters, but the market for robotic chassis is also increasing with the penetration of AI technology and expansion of applications across industries. Let's take a look at the different regions specifically. North America, especially the US, is the major growth region for the global robot chassis market. Widespread adoption of automated warehousing technology by large US e-commerce companies such as Amazon and Walmart is driving the demand for robotic chassis. This is particularly evident in the smart warehousing and logistics automation segment. Europe holds a significant position in the smart manufacturing and smart logistics sector and is expected to be one of the largest automated logistics markets in the world by 2025. The Europe robotics market is projected to grow at a CAGR of 14.3% from 2024-2031. The German market dominated the European robotics market in 2023 and is expected to realize a market value of $15.46 billion by 2031. In addition, the French market is expected to grow at a CAGR of 15.3% from 2024 to 2031. Chassis technology is being aggressively driven by companies such as KUKA, ABB, and Exotec in the Europe region, which are widely adopting high-load, high-performance robot chassis and automation systems for logistics, healthcare, and manufacturing industries to adapt to complex and changing operating environments. Then take a look at the market scenario in Asia Pacific. Grand View research reveals that the Asia Pacific mobile robotics market is expected to dominate the global market with the largest revenue share of 35.4% by 2024, owing to rapid expansion of the e-commerce industry and increasing automation in various industries. In addition, Asia Pacific is also facing challenges of aging workforce and rising labor costs, which further enhances the attractiveness of utilizing mobile robots for performing repetitive and physically demanding tasks. The growth of e-commerce and logistics has led to a surge in demand for warehouse automation and last-mile delivery in the region. In China, companies such as Reeman, Xiaosun, and Lifan Robotics are playing a significant role in logistics automation, industrial robots, and automation systems, further driving the popularity of automation in homes and businesses. For example, Reeman ships more than 2,000 robot chassis annually and has attracted more than 150 robotics companies to use its chassis in an open partnership model that serves a wide range of industries based on customer demand. The development of these companies and the wide application of their different products not only promote the development of China's robot chassis market, but also provide strong technical support for global intelligent manufacturing and automated logistics. The chassis market is becoming a key component of the growth of the robotics industry as companies demand more modularity and flexibility from their robotic systems. The revenue from mobile robots will surge by 2027. Factors driving this significant growth include advancements in artificial intelligence, increasing automation across industries, and growing demand for efficient logistics and warehousing operations. In addition to the traditional manufacturing and logistics industries, the introduction of AI has led to the gradual penetration of these robotic chassis into healthcare, retail, food service, and other sectors. Let's watch a video about the work of AI in conjunction with robotics to learn more about how AI is enhancing the intelligence of robot chassis, enabling them to perform tasks in more complex and changing environments.
Hi everyone, welcome to the BrightPick Demo Center here in Hebron, Kentucky. We're really excited to invite you in today to get a better look into the four walls of our facility where you will get to see the BrightPick Auto Picker live, up close and impersonal, and really get a good understanding to how the technology and the solution itself works, but also get a better understanding into the processes that we use every single day to make sure that you as the fulfillment teams are able to meet your customers' expectations with as little effort and as little people as possible. So come along with me, let's take a look at what I have going on behind me and get a better look at the BrightPick Auto Picker. So right now we are standing in the picking area for the BrightPick auto picker technology. So as you can see and look around on the floor, there's no QR codes, no wire guidance, no magnetic tape, no other form of navigational infrastructure that we would need to have the robots move autonomously and safely throughout the warehouse. So as the robots are moving around, they're utilizing the LiDAR technology, which is the same navigation system that a smart car would use to dynamically avoid any obstructions that come into its way. So if I, as a human, walk into the picking area, you can see that the robots are able to move and travel autonomously around me without causing any risk or threat to my safety or my well-being, which is great because a lot of the warehouses that we're designing for are brownfield solutions where cutting up the floor, adding any type of navigational infrastructure is just not realistic for what they're trying to achieve within their existing space. So we're able to really quickly drop in the robots. Once the system is mapped, we can easily move the furniture as well if the layout for the building needed to be changed. And we can know that the humans that are operating amongst the robots every single day are safe and at no risk to their own safety. So, now that we've gotten a good look at how the robots move throughout the aisles and throughout the paths in their workflow, why don't we take a closer look at the in-aisle robotic picking to see exactly how that works. Come on. So the coolest part about the BrightPick solution is actually the fact that we're the only ones that can do in-aisle robotic picking. So for in-aisle robotic picking, you're gonna see the auto picker travel autonomously out into the aisle. It's gonna use suction to extract the tote off of the shelving. And then once the chassis lowers down, you're actually gonna see a red flash. And that's our proprietary camera taking a 3D model of the SKU tote to drive the most successful robotic pick on the first try. So the robotic arm is going to articulate over, complete the pick, and then move it into the order tote, and then that pick is complete. And it moves on to either the next pick or to the next workflow once that tote is restored within the system. So because we're able to do all of the picking robotically in aisle, we're actually able to get higher efficiency because we're not wasting time traveling to and from a static location or having to rely on a human in a designated zone to work either with a manual cart or with another collaborative system. A question that comes up a lot is what happens when there are items that can't be robotically picked or are just better suited to be picked by a human? So for every one of our applications, we build a goods-to-person station as part of the solution. So the goods-to-person station, just like everything else, are made to be extremely flexible. When the auto pickers arrive, the human pickers are told right here on a machine interface what the pick is that they need to complete in the quantity that they need to make sure that they're picking accurately on the first try. This makes it extremely easy for associates to be able to walk up to the station, pick an item, mark it as complete, and it's ready to go to the next pick. From a training perspective as well, you can really take only a few minutes to get new associates onboarded onto the goods-to-person station and know that they're able to pick your orders accurately and ensure the highest level of customer satisfaction. So let's actually do this pick. So for this item, I'm being told to pick one box of Band-Aids from storage into the order tote. Once that pick is complete, I'm gonna mark this green button here, and the auto picker moves on to the next pick or to the next workflow in the operation. Another thing about the goods-to-person station is that, again, they're built to be extremely flexible. So we have a couple different configurations for the goods-to-person station. Our most popular, and the one that gets us the highest level of productivity, actually enables a human associate to be fed from 4 different locations around them at one time, enabling us to achieve up to 350 plus presentations per hour, helping the associate on one shift to get the highest level of productivity and the highest level of throughput without ever having to leave the station. Something else that's really cool about our system that not a lot of people actually know about is that we use dynamic slotting as part of our Intuition software. So the Intuition software is going to layer underneath your inventory management system, and it's going to look across your order profiles as well as their velocities to figure out the best placement of the SKUs within the system. So for robotically picked items, you're going to see that your fast movers or your A's and B's are going to typically be dynamically slotted here in these middle rows, or what we consider the sweet spot for the BrightPick auto pickers. For your slower moving items, your C's and your D's, they're going to start to gravitate towards the lower shelves here at the bottom as well as the highest shelves at the top. What's also interesting is for any SKUs that we know are always best picked by a human, you're going to see that those SKUs start to be dynamically slotted as close to your goods-to-person station or stations, depending on your application, and to minimize the travel between the pickup location from the SKU tote and the drop-off to the human at the goods-to-person, so that we're really eliminating, again, the travel distance per pick and making sure that we're increasing the overall efficiency and throughput of the system. What's great is that because our system needs so little human interaction to be able to run and to run effectively, we actually have the robots working tirelessly overnight to dynamically slot and make sure that all of the SKUs are ready for when you and your team walk in the morning to have the most successful shift possible from the first time that you clock in. Once all of the picks are completed by the Bright Pick solution, the auto pickers are going to bring the completed order totes to our pack-out station, which is typically the last workflow for the Bright Pick solution. So here you're going to see the auto picker raise the order tote to a specific shelf. It's going to drop that off. It's going to let your human associates know that this order is pick complete and ready for either greater consolidation with larger products or ready to be scanned and validated before it's shipped to your customers. So for the pack-out stations, just like everything else in the Bright Pick solution, they're built to be highly configurable and scalable, so we can do a simple pack-out station like you see here. If you have an increase in volume or peak seasons or anything else where you would need to have an influx of pack-out stations, we can always build additional ones right at the location, or we can place them throughout multiple locations within a single footprint. What's great also about our pack-out stations is that it doesn't have to be a shelving system. We can also drop completed work or completed order totes onto existing conveyor, or if you're looking to install a new conveyor, we can drop off once they're installed. So the system is really built to be able to make sure that everything from the outbound side is as effective and as efficient as possible for your associates to do what they do best to make sure your customers are happy at the end of the day. So now that we've gotten a look at how the picking happens for the Bright Pick solution and what happens once those picks are complete and ready to be shipped, let's go take a look at what happens at the decant station, which is how we get the product into the Bright Pick solution. So in addition to the picking process, we're also able to automate the storage, the put away, and the replenishment workflows within the system as well. So right now, we're standing at our decant station, which the decant station for us is where we induct the SKUs into the system. So as you can see, I have Dennis working beside me, and he just married this specific SKU to this tote. And what happened was he was delivered a case of product, he broke case for that specific SKU, he stored it within the tote, and now the system now knows when Dennis scanned this product that this will be ready for pickup for the auto pickers to move this tote back into the system. So for the totes themselves, you may have noticed that they're pretty standard totes. They're the same type of totes that you could walk into your local hardware store and pick up for yourselves. So for us, we're able to do a couple things with the totes. Typically, we're able to store a single SKU, single tote, for our products. We also have the ability for robotic picking to do 2 SKUs per tote. So the robot would then be able to essentially pick 2 different SKUs, either at the same time or different times, from one single tote, and that gives us the ability to build a little bit extra density and capacity into the system, making sure that we're making the most effective and efficient solution for your operations. Let's talk a little bit about our shelving. So our shelving, just like many other aspects of our solution, we're built to be extremely flexible and extremely scalable. So the shelving itself is standard shelving, the same type of shelving that you could walk into a hardware store to pick up, same type of shelving that honestly I have in my garage at home. So it has the ability to go up to 10 feet in height for buildings where we maybe don't have that clear space available. We have an existing deployment where we were able to utilize their existing mezzanine, which was about 6 feet in height. So we were able to utilize the existing clear space that they had, deploy the system, and we did a 6-foot shelving for that specific application. So we have the ability, again, to go up to 10 feet. And what's great is because the shelving is so simple, it's so pliable, you can easily unbolt it from the floor, move it to a new location in the warehouse, to a new facility, or simply just add shelving to the existing location that you have it deployed in. And it takes a matter of a few days to install. So once it's up and running, you just drop in the auto pickers, connect them to the Wi-Fi, and they're good to go. So it's really, again, built to make sure that for businesses of all sizes that need that flexibility, that need that scalability, that need to be able to make changes really fast and really easily, they don't have to worry about shelving that is bolted down and monumented into their building. You know, this isn't an industrial racking or any type of engineered structure. It's simple shelving that's really lightweight, and you can move it when you need to. Density is something that is becoming increasingly more important for our customers every single day. So as you can see here, the space between our totes is fairly minimal. And the reason for that is because we actually use suction for the extraction of our totes. So the suction would attach right here on the flat face. And if there are customers that need additional storage density or capacity within their existing footprint, we have the ability to take our existing shelving and build another shelf-supported mezzanine right on top. So a multi-level structure essentially, utilizing the same simple shelving for the BrightPick solution, just built right on top of each other. So we're getting the storage capacity not only from the placement of the totes being so close together per shelf, but also from the ability to go higher than a normal 6-foot racking, and then again being able to build on top of it. Just like the most productive worker, BrightPick Auto Picker does need to also rest and recharge. So our auto pickers are able to autonomously drive themselves to the charging station when they need to get an additional charge into their system. We also use something called opportunistic charging, which means that even if our robots are showing a high enough battery life, we're able to actually utilize slower times throughout the operations to have them get an even higher charge, meaning that when we need them for the highest efficiency, we are at 100% ready to go and there's no risk to the throughput for the operation. So that concludes our tour. We really appreciate you guys taking some time to come along with us to see exactly how the BrightPick solution works and to get a better look at the processes that we use to drive fulfillment for our customers every single day. So if you like this video, don't forget to give it a thumbs up and let us know in the comments what you thought of the tour and maybe what you guys want to see next. We'd love to do another video just like this for you, and we'd love to know what you'd like to see. So until next time, really appreciate you walking along with me. I'm Mary Glenn, and I'll see you guys next time.
By continually improving the intelligence of robots, these chassis systems will not only provide more efficient services, but also drive the digital transformation of the industry through personalized customer experiences. It is foreseeable that with the continuous breakthroughs in artificial intelligence technology, robot chassis will play an increasingly critical role in various industries in the future. The global market share of mobile robots expanded in 2024, and they are involved in various industries such as agriculture, industry, education, and healthcare. Next, look specifically at the role that the combination of artificial intelligence and robotics is playing in different fields. In the field of logistics and warehousing, the use of robot chassis technology is continuously improving efficiency and optimizing operational processes. For example, Amazon's robot chassis can autonomously identify items, optimize path planning, and efficiently move goods. Through machine learning, the robot not only improves warehouse handling capacity, but also reduces energy consumption through intelligent path selection. In industrial manufacturing, the role of robot chassis is even more important. For example, ABB's robots utilize artificial intelligence vision systems to accurately execute tasks, reduce human error and increase productivity. In agriculture, the combination of robot chassis and AI technology is also revolutionizing agricultural automation.
Monitoring involves the use of AI-powered sensors, drones, and satellites to monitor crop health, soil quality, and moisture levels. This technology can provide farmers with real-time data on crop growth and help them identify any issues before they become major problems. By monitoring crop health, farmers can take proactive steps to prevent crop damage and ensure a healthy harvest. 2. Precision farming. Precision farming involves the use of AI algorithms to analyze data on weather patterns, soil quality, and crop growth to optimize planting, fertilizing, and harvesting. This technology can help farmers optimize their crop yields and reduce waste by identifying the best time to plant, fertilize, and harvest crops. By analyzing data on weather patterns and soil quality, farmers can also make informed decisions on the type and amount of fertilizers and pesticides to use. 3. AI in livestock farming. Livestock monitoring involves the use of AI-powered sensors to monitor the health, behavior, and feeding patterns of livestock. This technology can help farmers identify any health issues before they become major problems and optimize feed and water usage. By monitoring livestock behavior, farmers can also identify any issues with feeding or watering systems. AI technologies can be used to farm waste management, in feed management, and to milk the animals. 4. Crop and soil analysis. Crop and soil analysis involves the use of AI algorithms to analyze data on soil samples to determine nutrient levels and recommend optimal fertilizer use. This technology can help farmers optimize their crop yields and reduce waste by identifying the best type and amount of fertilizers to use. By analyzing data on soil quality, farmers can also make informed decisions on which crops to plant and how to manage their fields. 5. Crop forecasting. Crop forecasting involves the use of AI algorithms to analyze data on weather patterns, soil quality, and crop growth to forecast crop yields. This technology can help farmers plan for the future and make informed decisions on when to plant and harvest crops. By forecasting crop yields, farmers can also make informed decisions on which crops to plant and how to manage their fields. 6. Weed and pest detection. Weed and pest detection involves the use of AI-powered cameras and sensors to detect and identify weeds and pests in crops. This technology can help farmers take corrective action before the damage is done and reduce the amount of pesticides used. By detecting and identifying weeds and pests, farmers can also make informed decisions on which crops to plant and how to manage their fields. 7. Irrigation management. Irrigation management involves the use of AI algorithms to analyze data on weather patterns, soil quality, and crop growth to optimize irrigation schedules and reduce water waste. This technology can help farmers optimize their water usage and reduce costs by identifying the best time to irrigate crops. By analyzing data on weather patterns and soil quality, farmers can also make informed decisions on when to irrigate and how much water to use. 8. Harvesting. Harvesting involves the use of AI-powered robots to harvest crops, reducing the need for manual labor and increasing efficiency. This technology can help farmers save time and money by reducing the need for manual labor and improving the quality of the harvest. By using AI-powered robots, farmers can also reduce the risk of injury to workers and improve safety in the field.
Robotic chassis can also be used in healthcare, elder care, military, advertising, and other applications.
Pardon me, may I get to that spot, please?
Meet Moxie, the robot.
Hello.
A high-tech nurse's helper rolling through hospitals around the country.
You'll see Moxie turning the corner and some patients and families are all turning heads trying to figure out, what this is.
The bot, developed by Austin startup Diligent Robotics.
We did not design Moxie to replace nurses. We actually are really focused on taking on some of the mundane tasks that fall onto clinicians' plate that can be automated.
Like delivering meds and collecting lab samples.
I have a delivery.
Programmed to lessen the load on overworked nurses, many of them pushed to the brink during the pandemic.
What we did start seeing is definite burnout in our staff. They were tired, taking care of patients who were sicker than they've ever seen before, and patients dying, many.
The chief nursing officer at Mary Washington Hospital in Virginia has 3 Moxies now helping out her team.
We found that there were many things that nurses do that really don't require a nurse.
I'm here to pick something up.
We bring the Moxie robots in, and they have to learn the environment by demonstration.
Moxie uses an AI navigation system and a robotic arm to help navigate doors and elevators.
We need Moxie to either deliver something to us or pick something up from our unit to deliver elsewhere. We can call it on the kiosk.
In minutes, Moxie responds to the call, loads up, and rolls away to deliver meds to another part of the hospital.
I think it's really kind of lifted a weight off of some nurses' shoulders that they don't have to leave their sick patient that they're monitoring to go do these little tasks.
Doman says all of Moxie's errands around the hospital have logged more than 100 miles. Miles her nursing team didn't have to walk themselves.
That's sizable. That's had an impact.
And Shep, Doman wouldn't talk about how much the hospital pays for Moxie, but did say it's a monthly service fee based on hours worked. And they see so much value in little Moxie. Get this, they're planning to add a 4th one to the fleet.
After understanding the basic applications of robot chassis in various industries, let's discuss the advantages and possible challenges of robot chassis. One of the major advantages of a robot's chassis is its adaptability. It can be used in a wide range of applications in many industries such as industrial, healthcare, logistics, and even in hazardous environments such as chemical handling or mining operations, where robots can replace manual labor and reduce the risk of workers being exposed to danger. In warehouse management, robotic chassis, like Fetch Robotics AMR robot chassis, can accurately navigate and improve efficiency, making the entire warehouse sorting system smarter. In addition, the robot chassis is highly intelligent. Through artificial intelligence and high-precision sensor technologies, such as laser radar and vision sensors, robots can sense their surroundings, autonomously avoid obstacles, and optimize path planning. However, the evolving robot chassis also faces a number of challenges. The first is the issue of high cost. Because it relies on advanced technologies such as artificial intelligence, sensors, and battery technology, customized robot chassis are usually not cheap and can feel burdensome, especially for small and medium-sized businesses. Another issue is battery life. While battery technology is improving, battery life is still a bottleneck in scenarios that require long hours of work, such as large warehouses. If the robot needs to work continuously for a long period of time, the battery can easily run out. In addition, some complex chassis designs can affect adaptability and make maintenance more difficult. This can lead to a lack of flexibility when switching between certain tasks, affecting the overall operational efficiency of the robot. So, in which direction will the future robot chassis go? First, there will be more intelligent features. The integration of artificial intelligence technologies will make robots more autonomous and able to perform tasks efficiently in complex environments. In addition, technologies such as telematics will enable robots to collaborate with other devices in real time, increasing efficiency. Another trend is lightweighting and better human-robot interaction design. Future robot chassis will become lighter, more adaptable to complex business environments, and able to interact more smoothly with humans. Robotic chassis will also become much more collaborative as 5G and edge computing technologies evolve. They will be able to respond to changes in real time, driving smart warehousing and industrial automation. In addition, energy management and wireless charging are key to the future. As battery technology improves, robotic chassis will have a longer range and be able to work with wireless charging systems to increase efficiency. Finally, with the development of cloud computing technology, the robot chassis will realize remote management and intelligent scheduling, and the whole system will become more flexible and efficient. This will promote the development of smart cities and intelligent logistics. Overall, the robot chassis is developing in the direction of being smarter, more efficient, and more flexible. Although there are still some technical and cost challenges, we can expect it to be widely used in the future as technology advances. Thank you all for watching.